Okay, workplace math students, today's lesson's kind of a different one. It's two parts to it. First part is conversions between measurements of volume and weight, and we're talking about bushels, which some of you probably have never heard before. The second part is going to be going from temperature in degrees Celsius to temperature degrees Fahrenheit. So this one is kind of for those that are looking to get work in the trucking industry because you're going to use bushels. Bushels is what you use for grain. So it's a volume measurement, okay? So it's a volume measurement. So if you think about the size of grain, it's this, that could be a size of grain, or that could be a size of grain, or maybe often grain has little fawns on it, little sticking out, and that's going to change how much volume the grain has in bushels, okay? So what we're going to do then, it also has different weights. So this one might be very heavy, this one might be very light, and this one might be medium. We don't know, because the density of the grain changes how heavy it is as well. So keeping that in mind, you're going to have a conversion factor, which will kind of tell us about how much weight per ton is that grain. So how heavy is that grain? And that's kind of a conversion factor that's going to be given to you. And each different grain is a different conversion factor based on its size and its density. Okay, don't need to worry about that too much. So the grain's weight is used to judge whether it's safe to carry for a truck to carry the load. So remember, with trucking, you got to be worried about your load weight. All right. And what you're really looking at is making sure that your brakes can work and you can stop in time, and your axles will also work. Because if it's too heavy, it's dangerous and it's illegal. So you got to make sure you can pull or transport the weight based on the weight maximum of the truck. And that's why we're kind of doing this. Each grain is a different weight, so we talked about that. So you're going to have a conversion factor between bushels and weight. That's going to be given to you. So let's give you an example, and you can see it's not very hard. So we have 2.5 tons of weight, and we have 39.368 bushels per ton. So we want to know basically what the weight is to see if it's as heavy as the truck. So all we do is we multiply them. All right, we take our conversion factor and we multiply it. So this here is your conversion factor that's going to be given to you. And you multiply it by the mass and you get the number of bushels. Okay. And so it's just a unit of measurement such as kilograms and for meters cubed, etc., etc. So there's 94.5 bushels of flaxseed when you have 2.5 tons. Now the other question is, if I give you how many bushels, say your boss told you, says, hey, I got 76 bushels of seed to haul, and can you haul it in your truck? Well, you look up your conversion factor, and say your conversion factor is, I don't know, say it's 40, say it's 31 bushels, 31 bushels per ton. So you got to figure out how much that weighs. So your boss is telling you this is what you have, and this is what you look up on your chart, and what you're trying to figure out is, what is the weight? So can you haul this on your truck? That's a very typical question for you to have, especially if you grow up on the prairies where you actually have lots of grain being hauled. So you would simply do this. You would simply take your total bushels, 76, and divide it by 31. And then when you divide it, so you're doing the opposite of what we did above, 76 divided by 31, that equals 2.45 tons. So 2.45 tons. That's a little t. So if it's a little t, remember that is which conversion factor? That is ton. Oh, let me look. So 2.45 with the little t is tonnage. Okay, and that's metric. So then from this, you can convert it to your other options. So you could then easily convert it into kilograms, and then you could easily convert it into pounds, lbs. Okay, so just keep in mind that the little t is tonnes. So for this question here, you just multiply it. Okay, here is my example, so you're going to divide. Okay, so you take this 900 bushels and you divide it by 39.368. Okay, this question here, let's not do this question with the cost. Okay, that's going to be a little bit above us for right now. This is the very typical one right here. Okay, so you got to figure out it in tons, then you convert it into kilograms, and make sure you use Google. Right, so type in and keep it accurate. So keep like 3 decimals, okay? And then you can convert it into pounds. And again, you want to use Google. So to figure out in tons, though, you have 45 bushels, and you have 73.847 bushels per ton. Okay, so you just multiply that together, and that'll equal your answer in ton. So then you can convert it into kilograms, and then from there you can convert it into pounds. All right, easy peasy, lemon squeezy, lbs. Good. So that's the first part of your lesson. The second part of your lesson is temperature. Now this is an easier one. So working with temperature, you got to keep some things in mind. We have 2 systems. We have the Fahrenheit, which is what Americans use, boo, and we have Celsius, which is what we use, yay. However, in your oven, when you're baking, and that's why we're doing this for workplace, when you're baking and cooking, you got to be able to go back and forth. So under our system, they figured out when water freezes, and they said, let's call that 0. And they figured out when it boiled, and they said, let's call that 100. And then they just did equal marks. So in the imperial system, it's really weird. It freezes at 32 degrees Fahrenheit. Weird. And then it boils at 212 degrees Fahrenheit. What? It's a lot higher temperatures, okay? So typically Fahrenheit's higher. Now if you go low enough, then it inverses. But it's so low, it never really happens. So let's just go here with us. We have our Celsius. This one is very, I find that this really helps us see this. Celsius and Fahrenheit. F-A-H-R-E-N-E-I-T. Okay, so cooking, baking, those types of things, or of course you're melting metals or you're welding, you need to kind of know this, and that's why they put it in here. So this one here is water freezes. And at Fahrenheit, it's 32 degrees. And at Celsius, it's 0 degrees. And then here we have water boils. Oops, let's make that a B-O-I-L-S. It boils for us, it's 100 degrees Celsius. For those Americans, it is what? Actually, let me change that to blue writing so it stands out. This is 100, 0 degrees for freezing, 32 degrees and 212. I mean, that's just ridiculous. There's no sense to it. But remember, it was made up for other reasons, okay? Good. And then some are down here. Okay, so typically these are higher numbers. That's the generalization. And these are typically lower numbers. Okay, but if you go low enough, then it flip-flops. Okay, then this, if it comes really low, let me write that down even further because it's such a weird thing. Okay, so if it gets really low, then once it gets low enough, this here would be lower, and this would be higher. And I think it's around minus 30 or something like that. But you can look that up. Okay, so which you have to be, the other part, of course, when you're talking about weather, edit, undo. When you're talking about weather, that happens as well. Why is that E there? Okay, let me do a space. No. Come on, thing. Okay, undo, undo, undo. Just let that be there. Ha ha ha. Okay, so basically there's a math formula that you can use right here. So if you have Fahrenheit, you would enter it in, you would subtract it, you'd have to do this first, then you would multiply by the fraction 5/9. Okay, for the Fahrenheit though, it looks very similar, but there's no brackets, so that makes your math different. You would multiply first. Because there's no brackets, you got to do your multiplication following BEDMAS. So you multiply first, then you would add. Okay, so very different with your formulas and how you do it. For us, we are going to use Google. All right, so real quickly here, 42 degrees Fahrenheit in Seattle. What is that in Celsius? Okay, so you want to go going down the Mariners game. You want to know, hey, do I have to wear a jacket? Do I need a sweater? So simply go to Google and convert. I don't want to ruin that. Convert. Start with that word. 42F to C, right? 42 Fahrenheit to Celsius. You can see it even popped up down here. But boom, there it goes. There's Google's converter. So it's 5 degrees Celsius. You think you need a jacket? Damn right. It's pretty darn cold. Okay? So it's important to know that. Next one. On a hot summer day, it's 48 degrees Celsius. Well, what is that in Fahrenheit? 48 degrees Celsius. So go to Google. Now we can type in either one of these. We'll type in this one, 48. And look, there's your answer, 118 Fahrenheit. So you often hear in the States, oh, it's over 100 degrees. Well, what is 100 degrees? Let's type it in. 100 degrees is 37.7. Is 100 degrees hot? Yes, it is. What about, oh, it's in the 90s, right? It's mid-90s, 32 degrees. There you go. When I went to New York and Philadelphia and Washington last summer on the East Coast, it was like over 90 degrees all the time. It was crazy. In fact, one morning is really cold. And I thought, oh man, it's so cold. We're like, yes, it feels like it's cooling off. We look at the thermometer, and it's 27 degrees. And this was like at 8 in the morning. 27. Whew. So what would that have been? Well, Americans would have said it's 80 degrees. There you go. Okay. So you can see this number's a lot higher. This number's a lot lower. That's always true. But if you get into like minus 32, you can see now this one's lower. This one's higher. So let's go minus 42. And so now this one is lower. This one's higher. So minus 46. And now you can see this one's lower. So now it's inverted around minus 45, 40-ish. Okay? Do you need to know that? Not at all. You got to be able to convert. And our generalization is what? Our generalization is that generally, Fahrenheit's higher numbers. And generally, okay, generally, Celsius is lower numbers. And that's really always the case until you get so low that it inverts. Okay, so you should be able to work with those numbers for all the different reasons of cooking, baking, as well as warming up metals, so on and so forth. Let's make this one easy. Let's get rid of C and D. So these are, yeah, come on in.
Sorry, what are you recording?
1 second, guys. Wait, let's cross off these ones here. We won't do E, and we won't do F. That's too high. Okay, so we'll do those four there. 21 is good because that's room temperature. So usually in school, they set the classrooms to 21 degrees. I like my house at 20 degrees because upstairs and it's 21 degrees. All right. Good. Going back then, convert the following temperatures to Celsius. Uh,